Ever wondered how a message is transmitted from one device to another? Well, it's all thanks to a 7-layered cake of technology known as the ISO-OSI model. This model, short for International Standards Organization Open Systems Interconnection, is the backbone of computer networking. It's like a universal translator, allowing different devices and networks to communicate seamlessly. Now imagine sending a message from your computer. It's not as simple as hitting send. This message is broken down, packaged, addressed, transported, and then reassembled at the other end. Intriguing, right? Each layer of the ISO-OSI model has a specific role to play in this process. From ensuring the physical transmission of data to managing sessions between applications, these layers work together to ensure that your message reaches its destination intact and on time. So, let's dive in and unravel the mystery of each layer of the ISO-OSI model. Starting from the bottom, the first layer is the physical layer. Now, what does this mean? Well, the physical layer is the basis of all communication systems. It's where the raw, unprocessed data gets transmitted. But not as complex messages or files, no. Here, data is transmitted as a simple bit stream, a series of ones and zeros over a physical medium. This could be a wire, a cable, or even through the air in the case of wireless communication. The physical layer doesn't concern itself with what the data represents or how it's organized. Its job is to deal with the mechanical and electrical aspects of the system. It determines the type of signals to be used, how the devices will connect and disconnect, and the data rates. It's all about getting the data from one place to another, no matter what it is or what it means. In essence, the physical layer provides the means to transmit the data. Moving up, we reach the second layer, which is the data link layer. Imagine it as your meticulous postmaster. Just as the postmaster ensures your letters reach their destination without any errors, the data link layer takes responsibility for error-free transmission of frames from one node to another. But how does it do it? It manages the chaos of the physical layer, protecting it from its limitations. You see, the physical layer with all its electronic signals and bits can sometimes be a bit messy. It's like a bustling marketplace, full of noise and potential for errors. The data link layer, however, ensures order. It checks for any errors that might have occurred in the physical layer and corrects them. It's like a quality control inspector, double-checking everything before it's sent off. So the next time you send a data packet, remember the diligent data link layer. The data link layer ensures that what the physical layer transmits arrives intact. Next up is the network layer. This layer plays a critical role in the ISO-OSI model. Its primary responsibility is the transmission of data from one host to another. But not just any hosts, these are hosts located in different networks. Think of it as the Postmaster General of data transmission, ensuring that data packets are delivered to the correct address, even if it's halfway across the world. But that's not all. The network layer also takes on the challenge of managing network congestion. When data packets are like cars during rush hour, it's the network layer that keeps things moving smoothly. It determines the best possible route for each data packet, ensuring they reach their destination without getting stuck in traffic. So, whether it's routing data packets, managing network congestion, or transmitting data across networks, the network layer is the unsung hero, making sure everything runs like clockwork. The network layer takes care of data packet routing and congestion control. The fourth layer is the transport layer. This layer plays a crucial role in the ISO-OSI model. It's the heart of the system, ensuring reliable and transparent transfer of data packets from one host to another. But how does it do that? Imagine you're at a crowded party. You're trying to have a conversation with someone on the other side of the room. The noise, the people moving about, it's all a bit chaotic. The transport layer is like your personal party organizer. It controls the flow of data, ensuring that your conversation is heard correctly and in order. It's like threading your words through the crowd, making sure they reach the right person in the right order and without any interruptions. The transport layer doesn't just control the data flow, it also takes care of data integrity. It checks for errors, and if any are found, it resends the data. It's a vigilant guardian, ensuring that your data isn't lost or duplicated. The transport layer ensures data is delivered error-free, in sequence, and with no losses or duplications. Finally, we have the session, presentation, and application layers. Let's unravel these final layers and explore their functionality. Starting with the session layer, this is essentially the network's concierge. When two applications want to communicate, The session layer steps in to set the stage. It establishes, manages, and terminates the communication sessions between these applications. Think of it like a switchboard operator, connecting calls and then disconnecting them when the conversation is over. Moving up to the presentation layer, this is where the syntax and semantics of the information exchanged between systems is handled. In simpler terms, it's the translator. It ensures that the data sent by one system can be understood by the other. It's also responsible for data compression and encryption. So this layer is like an interpreter, making sure that everyone speaks the same language and ensuring that the conversation remains private and efficient. Lastly, we reach the highest level, the application layer. This layer is the bridge between the network services and the applications that use them. It enables software applications to negotiate and manage network services. It's like a middleman, facilitating a smooth interaction between the software applications and the underlying network. This layer is also home to protocols like HTTP and SMTP, which you might recognize from browsing the web or sending an email. So to visualize it, if the entire ISO OSI model was a restaurant, the session layer would be the maitre d', the presentation layer the interpreter for international guests, and the application layer the waiter serving you your food. These top layers collectively ensure that the network performs as a seamless, reliable entity. The ISO OSI model is a complex but essential part of computer networking. This 7-layered model is like a well-oiled machine, with each layer playing a vital role in the process. Let's take a quick jog down memory lane to revisit these layers. We kick things off with the physical layer. It's the most fundamental, dealing with the physical aspects of transferring data such as electrical voltages and pin layout of cables. It's all about turning the digital data into signals that can travel over a network. Then we have the data link layer, which ensures that these signals are transported error-free from node to node. It's like a traffic cop, managing the flow of data packets and making sure they don't collide. Moving up, we come across the network layer. This layer is like the GPS of the model. It determines the best route for data packets to reach their destination, taking into account factors like network congestion and the cost of various routes. Next in line is the transport layer. It's the layer that ensures data is delivered from the source to the destination correctly and in order. Think of it as the courier service of the model, delivering your packets safely and on time. Finally, we have the session, presentation, and application layers. These top 3 layers work closely together to establish sessions, format data, and provide network services to applications. They're like the customer service desk, making sure the user's needs are met and their experience is seamless. In essence, the ISO OSI model is a blueprint that guides the transmission of data from one device to another. Each layer has a unique role, but they all work in harmony, like a symphony orchestra, each playing their part to create a magnificent performance. They ensure that communication between devices is smooth, efficient, and error-free. So whether you're sending an email, browsing the web, or streaming your favorite show, remember, it's all made possible by these 7 layers working their magic behind the scenes. Remember, understanding the ISO OSI model is the key to mastering computer networking. So that was a quick tour of the ISO OSI model. We've journeyed through the 7 layers, each with its unique role in the grand scheme of data transmission. But remember, this is just the tip of the iceberg. Each layer is a vast field in itself, with intricate processes and protocols that couldn't possibly be condensed into a 10-minute video. The beauty of the ISO OSI model lies in its complexity and the seamless interplay of layers. We encourage you to delve deeper, to explore more about each layer, how they interact with each other, and how they collectively make communication between devices possible. Did this video spark any questions? Are there any aspects of the ISO OSI model you'd like us to delve into more? We welcome your thoughts and comments, so don't hesitate to share them with us. Thank you for staying with us. We hope you found this exploration of the ISO OSI model enlightening. Until next time.